In the previous section, we talked about trig functions, and we just kind of introduced trig functions in general, but you might be curious to know why we care about trig functions. And there are all sorts of applications of trig functions, which you probably saw in your trig class. You should have seen several applications in your trig class. And here I am assuming that you've all had trig, right? You may have never had a formal trig class, but you've probably seen trig. I'm assuming that you've been exposed to trig at the high school level in some form or another. So maybe you haven't seen a ton of applications of this stuff, but suffice it to say that trig functions are very useful for solving equations, or for solving triangles, sorry. And in particular, they're helpful for solving right triangles, but we can use them to solve other kinds of triangles as well. We'll see this in future sections. In this section, I just want to talk about solving right triangles. Now, sometimes in order to solve a triangle, you have to take the inverse of a trig function. So we'll talk about inverse trig functions as well, although that's a topic that we'll explore in greater detail in chapter 6. Just the concept of inverse functions in general is something that we'll talk about in chapter 6. But yeah, so for this section, we're going to talk about solving right triangles, which will maybe give you some sense for why we care about trig functions. And then we'll also talk about inverse trig functions. So to solve a triangle means to find all of the angle measures and side lengths of the triangle. So let's practice. Let's solve right triangle ABC if A is 60 degrees and C is 9. So we know that it's a right triangle. And we know that A is 60 degrees and that C is 9. So let's see if we can solve this thing. Now we can't really use Pythagorean Theorem to get these two sides, because we only know one of the sides and we need to know at least two of them in order to be able to solve for the third. We can get this angle pretty easily, right? We can get, angle B should be 90 degrees minus 60 degrees, since A and B are complementary. So angle B is 30 degrees. That's easy enough. And of course, angle C is 90 degrees. That's given just from the fact that the triangle is a right triangle. But how do we find sides A and B? How do we find those two sides? Well, this is where trig comes in handy, right? You could say something like sine of 60 degrees is A over 9, right? So we can say sine 60 degrees is A, but it's A over 9, right? So to solve for A now, we would just multiply both sides by 9. We get A equals 9 times sine of 60 degrees. 60 degrees happens to be one of those numbers on the unit circle, right? We know that sine of 60 degrees should be root 3 over 2. So this is going to be 9 times root 3 over 2. Or I guess you could say 9 root 3 over 2, right? Okay, so there's A. If you want a calculator approximation, you can, of course, get one. You can say 9 root 3 over 2 is approximately 7.8. Okay, so that's that. Now for B, you could do something similar, right? You could say B is this, so this is A and this is B, right? So B, you can say cosine of 60 degrees is B over 9. So you say cosine 60 degrees is B over 9, right? So B is 9 cosine 60. That's 9 halves, or 4.5 if you like. Right? Because cosine of 60 degrees is 1/2. So there you go, right? That's how we solve a triangle. So we've got all of the missing parts. On a test or a quiz, I'd really appreciate it if you would list out like your answers. Just easier for me to grade. if you would just say something like, okay, so we figured out that B was 30 degrees, that A was 7.8, and that B was 4.5, right? That way it's a little bit easier for me to check. So that's that. See if you can do part B on your own. So I'll let you work on it. Go ahead and give me a decimal approximation. Round to 2 decimal places, okay? Round to 2 decimal places. Okay, here's my solution. So I think A is going to be 48 degrees. Oops. So if I wanted to find, say I wanted to find B, I could use tangent 42 degrees. I could say tangent 42 degrees is B over A. Gotta make sure I'm in degree mode. So that's about 3.33. Okay, so that gives me side B. Now if I wanted side C, so if I wanted to figure out the hypotenuse, well at this point I could use Pythagorean theorem, right? I could say 3.7 squared plus 3.33 squared equals C squared. I wouldn't advise that though. The reason being that in order to get this answer, you did some rounding. So now if you use that answer to get this answer, you're going to be off by a little bit because you're going to have some rounding errors. My advice would be stick with the original information you were given as much as possible. So in this case, instead of using Pythagorean theorem at this point, I might do something like cosine of 42 degrees is A over C, right? So that means that C is 3.7 divided by cosine of 42 degrees, okay? That's a much better way to approach the problem because you're not going to have rounding errors here. 3.7 divided by cosine of 42 is about 4.98. So there we go, right? We discovered that A was 48 degrees, that B was about 3.33, and that C was about 4.98. Okay. So that's that. That's how we solve right triangles. Oh, I have one more. And this last example will show you why we need inverse trig functions, I think. So let's see. We've got a right triangle. A, B, C. We know that A equals 4. We know that B equals 4. We don't know what C is. But we also don't know either of these two angles. So so how are we going to find those angles? Well, what we could do is we could use the fact that we know what these two sides are, and in fact, we could use Pythagorean theorem to figure out what C is, right? Let's do that just right off the bat. So we'll say A squared plus B squared equals C squared. So 16 plus 16 is c squared. That means c is going to be square root of 32. Oh, 32 is 16 times 2, right? And square root of 16 is 4, so this is 4 root 2. Okay, so we know that c is 4 root 2, but how do we get the angles, right? Well, to get the angles, we could use a trig function. We could say something like, using the original information, I would say something like this. Tangent of b is opposite over adjacent, right? Tangent b is 4 over 4. In other words, tangent b is 1. But see, our goal is to solve for b. So the question is, how do you do that? Well, you would solve for b by taking tangent inverse of both sides, okay? Another way to think about this is that you're looking for an angle such that tangent of that angle is equal to 1. What angle do we know does that trick? And the answer is 45 degrees, right? Tangent of 45 degrees equals 1. So that's how we know that B must be 45 degrees. Okay. Then you can do the same thing for angle A. Angle A, in this case, also is going to happen to be 45 degrees. But you would do the same thing, right? You would say tangent A. Tangent A is opposite over adjacent. So it's 4 over 4, which is 1. And that implies that A is also 45 degrees. Okay? Or you could just use the fact that A and B are complementary. So if B is 45, A has to be 45, right? But there you go. We have our answers now. C is 4 root 2. B is 45 degrees. And A is also 45 degrees. Okay? So, so this leads us to want to look at things like inverse functions, because in this case, right, in this case we didn't need a tangent inverse because we could figure out, like we knew that 45 degrees would satisfy this equation. But what if instead of tan b equals 1, we had something like tangent b equals, 4.73 or something? It's like we have no idea what angle would give us 4.73 when we apply tangent to that angle, right? Like that's not a value that we have memorized. So to figure those things out, we use inverse trig functions. And so for now, just use a button on your calculator. You should be able to find the inverse trig buttons on your calculator. But so let me give you an example of this. So let's solve this triangle. We know that B is 24.5. We know that C is 36.9. Okay. So right off the bat, I can get this third side by using Pythagorean Theorem. I can say x squared plus y squared equals r squared. So x squared is going to be 36. I'm just going to use my calculator. So it's going to be 36.9 squared minus 24.5 squared. That comes out to 761.36. Then I'm going to take the square root. And that's a nasty number, so actually I'm just going to round. I'm going to say x is approximately 27.6. Okay, so 27.6. So I know that much. I'm not going to use that information as I move forward through the problem because I've rounded it and I don't want there to be rounding errors in my answer. But I know that x is about 20, or instead of calling it x, maybe I should have called it a, right? Should have called it a. So I know that a is 27.6. Okay, But how do we find the angles? Well, we're going to have to do the same sort of thing that we did before. We have to use a trig function that uses this side and this side. So let's say that I want to focus on angle A to figure out what angle A is. I can say something like cosine A is 24.5 over 36.9, right? Since it's adjacent over hypotenuse. So I'm going to say cosine A is 24.5 over 36.9. And that's a nasty number too. In fact, so 24.5 divided by 36.9 is about 0.663957, right? So I could, excuse me. So I could try to think about an angle such that cosine of that angle is equal to 0.663957, but you're not going to be able to think of one. I mean, unless you're some kind of super calculator brain genius, like you can't just do that in your head. It's not a value that we have memorized. So instead, what we're going to do is we're going to take cosine inverse, right? So if you take cosine inverse of both sides of this equation, the cosine inverse and the cosine will cancel and just leave you with A. So you're going to get A equals cosine inverse of 24.5 divided by 36.9. Let me just say, students sometimes do something really foolish. When they see cosine A equals this and they're trying to solve for A, they'll divide both sides by cosine. If you do that, I'm just going to fail you. if you do that, you deserve to fail the class. This is not multiplication. It's not cosine times A. Cosine in and of itself, cosine is just a function. It doesn't have any numerical meaning by itself, right? You have to take cosine of something. This is cosine of A, and you can't undo it by dividing. Don't be ridiculous, right? You undo a function by taking an inverse function, right? So we undo the cosine by taking cosine inverse of both sides. So this is what you would punch into your calculator to get the answer for what A is. So I'm going to do cosine inverse of 24.5 divided by 36.9. So that's about 48.4 degrees. Okay, and then I could do the same thing with B. With B, I think I would use the sine function, right? Opposite over hypotenuse. So I could say sine B is 24.5 over 36.9. And that implies that B is sine inverse of 24.5 over 36.9. So on my calculator, sine inverse 24.5 over 36.9. That comes out to about 41.6. Okay, so A, little a, is about 27.6. Angle A is about 48.4 degrees. And angle B is about 41.6 degrees. Okay, and that's how we would solve a right triangle using an inverse trig function when necessary. Okay, so while we're on the subject of inverse trig functions, let's review a little bit about them because they're a little bit trickier than it might seem at first glance. So one thing that you might recall from your trig class is that the inverse trig functions are not true inverses in the sense that it's not always true that trig inverse of trig of theta equals theta. This is a true statement if theta is an acute angle, but if theta is not acute, then you need to be a little bit more careful than that. Okay. The reason that we don't have true inverses for the trig functions is because the trig functions are not one-to-one. And we'll talk about this in greater detail in chapter 6, but for now, suffice it to say that whenever you take sine inverse of some number, it's going to give you an angle that's somewhere between negative 90 degrees and positive 90 degrees. Whereas when you take cosine inverse of some number, it's going to, the calculator is going to spit out some angle between 0 degrees and 180 degrees. Okay, so the range of the inverse trig functions is kind of tricky. For sine, it's negative 90 to 90. For cosine, it's 0 to 180. But they all kind of have that format, right? Tangent will map you somewhere between negative 90 and 90. Cotangent will map you somewhere between 0 and 180. Secant will map you somewhere between 0 and 180, except for 90 itself, because secant 90 is not defined. Cosecant will map you somewhere between negative 90 and 90, except for 0, because cosecant 0 is undefined. Okay. So for example, whenever you see sine inverse of 1/2 equals x, what this means is that sine x equals 1/2, and that x is between negative 90 and positive 90. Okay, that's important to know, right? Because it explains why when you type in sine inverse of 1/2, you only get 30 degrees into your calculator. You don't get 150, 390, and so forth. Even though sine of 150 is also 1/2, and sine of 390 is also 1/2, there are infinitely many angles such that sine of those angles is equal to 1/2, but only one of them lives between negative 90 degrees and positive 90 degrees, and that happens to be the 30-degree angle that your calculator will spit out to you. Okay. Yeah, so, and that's what I'm saying here. So in other words, while it's true that sine 30 degrees equals 1/2, sine 150 degrees equals 1/2, sine 390 degrees equals 1/2, and so forth, only 30 degrees is between negative 90 and 90, and so sine inverse of 1/2 equals 30 degrees. Okay, as another example, cosine inverse of 1/2 equals x would mean that cosine x equals 1/2, and that x is between 0 and 180, because that's where cosine maps us to. Okay, more about this in chapter 6, but for now, just remember this, right? Remember this, and remember to apply these facts. Let's see if we can calculate some of these function values without using a calculator. So cosine inverse of √3/2. We would be looking for an angle between 0 and 180, such that cosine of that angle is √3/2. So that would have to be 60 degrees, right? No, not 60 degrees. It would be 30 degrees. 30 degrees. Remember, cosine goes with the x values, so it's going to be the smallest. It's going to be the smallest angle, right? It's going to be the smallest angle, so that you get the largest possible x value. So that's going to happen at 30 degrees, right? 30 degrees for sure. Cosine inverse of negative √3/2. Now this has to be an angle between 0 and 180, such that cosine of that angle is negative √3/2. So cosine, in order to get a negative value, you're going to have to be in quadrant 2 or quadrant 3, but you're restricted, right? You're restricted so that theta has to be between 0 and 180. So you know you're not in quadrant 3. So you must be in quadrant 2. You know that cosine of 30 degrees is negative √3/2. That means the reference angle. So that means the angle you're looking for is in quadrant 2, and that it has a reference angle of 30 degrees. Okay? So what's going to do the trick? Well, to get from here all the way to here would be 180 degrees. Minus 30 degrees must be 150 degrees. So theta must be 150 degrees. Okay, we can do the same thing with the sine. Sine inverse function. All right, sine inverse of √3/2. Now that would be 60 degrees, right? That would be 60, sorry. That would be 60 degrees for sure. Sine inverse of negative √3/2. Now here we have to be careful. So remember, sine inverse is going to map us somewhere between negative 90 degrees and positive 90 degrees. So you're going to be somewhere here in quadrant 4 or quadrant 1. Okay. So you're somewhere here in quadrant 4 or quadrant 1. And since sine is negative, it must be quadrant 4. You must be in quadrant 4 somewhere. So this is the idea. You must be here in quadrant 4. You know that the reference angle, so this is the angle that you're interested in right here. And you know that the reference angle should be 60 degrees. That means that this angle should be negative 60 degrees. Okay, it's the same value, but just going in the clockwise direction. So sine inverse of negative root 3 over 2 should be negative 60 degrees. Anyway, you can verify all of this on your calculator, but working through it mentally will help you to establish this firmly in your mind. So if I ask you to do something without a calculator, that's because it's going to help you to understand the concepts. It's going to help you to understand conceptually what's going on. So do practice, right? Do practice doing this kind of stuff in your head without using a calculator. Let's go through some more. Tangent inverse of tangent of pi over 3. Remember, this is not necessarily pi over 3. I think it will be in this case because pi over 3 is acute. Okay, but as we'll see in part F, tangent inverse of tangent of 2 pi over 3 is not 2 pi over 3. So and we'll see why. So, but let's work out part E. So tangent inverse of tangent of pi over 3. This is going to be tangent inverse of tangent pi over 3. Now let's see. Pi over 3, we are at the point 1/2 root 3 over 2. 1/2 root 3 over 2. Okay? So tangent is going to be root 3 over 2 divided by 1/2. That's just going to be root 3. Okay? So now tangent inverse of root 3, we'd have to think to ourselves, what's an angle? And for tangent, we map between negative 90 degrees and positive 90 degrees. So we need, what's an angle between negative 90 and positive 90 such that tangent of that angle is equal to root 3? Well, that would have to be pi over 3, right? That would have to be pi over 3. So that's that one. That one's easy. What about part F? Tangent inverse of tangent of 2 pi over 3. So tangent of 2 pi over 3. At 2 pi over 3, we're at the point negative 1/2 root 3 over 2. Okay, so tangent inverse of tangent of 2 pi over 3 is going to be tangent inverse of root 3 over 2 divided by negative 1/2. So that's going to be negative root 3. Well, so now we're thinking, we have to think of an angle that lives between negative 90 degrees and positive 90 degrees, or negative pi over 2 and positive pi over 2. Since we're working with radians, let's stick with radians. So we're looking for an angle between negative pi over 2 and positive pi over 2 such that tangent of that angle is negative root 3. So we must be here in quadrant 4. So you can see that we're not going to be mapping back to 2 pi over 3 because the angle we're looking for has to be here in quadrant 4, right? This is the angle that we're looking for. But it should have, well, let me think about this. It should have the same reference angle as 2 pi over 3, which was pi over 3, right? So it should still have a reference angle of pi over 3. But since theta is being measured in the clockwise direction, we're going to say theta equals negative pi over 3. Okay, so there's a clear example where tangent inverse of tangent of some angle is not necessarily the same angle, right? It does work out when the angle is acute. When the angle is not acute, it doesn't always work out. But again, you can verify this on your calculator, right? So we could say something like Well, let me make sure I'm in radian mode real quick. You could say something like tangent inverse of tangent of 2 pi over 3 is negative pi over 3, right? So it's kind of this weird, interesting thing, but that's why your calculator gives you what it does. Let's look at some places where we mix and match a little bit. So let's look at sine of cosine inverse of negative 3/5. So this is where it really comes in handy, I think, to say, we'll say that theta equals cosine inverse of negative 3/5. Now, what does that mean? From the previous page, we talked about what that meant. We said cosine inverse of 1/2 equals x means that cosine x is 1/2 and that x is between 0 and 180. So it's going to be the same idea here. Theta equals cosine inverse of 3/5 means that cosine theta is negative 3/5 and that theta is between 0 and 180. Okay, both of those conditions have to be met. That's important information because that tells us where theta lives. So if I draw a picture now, theta has to be between 0 and 180, so it's in quadrant 1 or quadrant 2. Since cosine theta is negative, it must be in quadrant 2. So there's theta. Now cosine theta is negative 3/5. That's negative 3 over 5, adjacent over hypotenuse. We want to figure out what sine of cosine inverse of negative 3/5 is. Well, cosine inverse of negative 3/5 we said was theta. So really we want to figure out what sine theta is. Sine theta is going to be opposite over hypotenuse. So we need to figure out what the opposite side is here. So we're going to say x squared plus y squared equals r squared. So 9 plus y squared equals 20 squared equals 16. Y equals plus or minus 4. Now I need to decide, is it going to be positive 4 or negative 4? And it looks like since I'm in quadrant 2, I'm going to take positive 4, right? Because I'm up here in quadrant 2. So now I can figure out sine theta pretty easily, right? So sine of cosine inverse of negative 3/5 is the same thing as sine theta because we 4/5, right? Opposite over hypotenuse. Okay. So there you go. Now, this condition is very important because if you didn't have this condition, if all you knew was that cosine theta was negative 3/5, then you wouldn't know if theta is in quadrant 1 or quadrant 2 or quadrant 3. And that's important to know because if theta is in quadrant 2, then y is positive. If theta is in quadrant 3, then y is negative, right? So if you don't know which quadrant it is in, if you don't know which quadrant theta is in, then you can't get the right value for sine theta. So that's why you have to know this extra condition, right? You have to know that the ranges of the inverse functions in order to correctly do these kinds of problems. Let me give you one more example. A tangent of sine inverse of negative 12/13. So I'm going to do the same trick, right? I'm going to call this thing theta, right? I'm going to say theta equals sine inverse of negative 12/13. What does that mean? That means that sine theta is negative 12/13 and that theta is between negative 90 degrees and positive 90 degrees, right? Okay. So I know that theta is between negative 90 and 90, so that means theta is in quadrant 4 or quadrant 1. Since sine theta is negative, that means theta must be in quadrant 4. Now sine theta is y over hypotenuse, that's negative 12 over 13. And now I can solve for this missing side. And again, you can see that since I'm in quadrant 4, x is going to be positive. So when I solve for x here, I'm going to take the positive value. I'm going to say x squared plus y squared equals r squared. So x squared is 169 minus 144 is 25. X is plus or minus 5. But I'm going to take the positive version because I'm up here in quadrant 1. X is positive there. Or quadrant 4, but x is positive there. So now I can figure out tangent pretty easy, right? Tangent of sine inverse of negative 12/13 is really the same thing as tangent theta. And tangent theta is opposite over adjacent, negative 12/5. Okay. And that's that one. That'll do it for this